Okay, sample problem 1.4. The diagram in A shows a compound made up of atoms of two elements, represented by the green and the red spheres in the liquid state. Which of the diagrams in B to D represent a physical change, and which of the diagrams represent a chemical change? Okay, so here's really how we can approach this. In a chemical change, I'm going to represent two different atoms. One is open, the other one is shaded in there. That's a substance. It's really what we would call a compound because it has two different elements in it. If the relationship between those two atoms changes, meaning that they are no longer attached to each other after a process has occurred, or if more have been added or others have been added to it, that would be a chemical change. So here would be an example. You might have them separated. That's a chemical change. Or what might happen is another one gets added. That's a chemical change. Or they split up and combine with each other. That's a chemical change. Okay? Those are all chemical changes. Now, physical changes essentially would be something like this. There's a bunch of them close to each other or far apart from each other, and that relationship changes. So, for example, they're now far away from each other. That's a physical change, right? We haven't changed the relationship between the particles in the substance. That's called a substance right there. These are also substances. These substances are different than that substance. But here, that's your substance. That's still a substance, right? It hasn't changed at all. It's not near the other molecules. It's not near the other substances, but it's still the same substance. So that's really what you're looking at. So if you look in part B, there's definitely a change that's occurred, a chemical change. Because what's happened is, I'm going to use open and shaded to represent colors. What's happened is, now the open ones are together and the shaded ones are together, right? That's essentially what happened. So that's case one over here. That's chemical. So B is a chemical for sure. Now we can't see atoms. We can't see molecules, at least under most circumstances. So we would have to use indirect information to see that happen. This is really just a conceptual question so that you understand what we mean by chemical and physical change. And this is one interpretation of it. So let's try cell C. Cell C, they're completely separated, right? So essentially what's happened is, these are now all separated. So this substance is completely different from this one now, but before they were together. So that's another chemical change. You know, we often think of a chemical process in one in which the atoms are rearranged. But really what we mean is they're rearranged at the molecular level, meaning that these two are attached to each other. You know, they're still attached to each other here, so that's a physical change. But here they're separated. They're not attached to anymore, so that's a chemical change. Okay, part D, if you take a look at those, and again, you're comparing them to cell A. In cell A, they're close to each other, but the relationships are the same. In part A, they're just really close to each other. But in part C, they're still attached to each other. It's just that they're further apart. So that's a physical change. Okay. Again, in practice, we would have to use observations about the behavior, it's sometimes difficult to tell whether something is a physical or chemical change by looking at it. Something might, its appearances change during chemical. So for example, during physical. So if I melt water, its appearance changed. So isn't that a chemical change? And the answer is no. A physical change can be thought of as a process where it's essentially, it could be reversible. So if you melt water, you can refreeze it and it's still water. But inherently, really at a deeper level, the question is, what is water? And water is H2O, right? That's water. 2 hydrogens and 1 oxygen. And that's what the structure is if it's a liquid. But it's also the same structure if it's a solid, if it's ice. Liquid, water, and ice. So that's not a chemical change. When something melts, freezes, boils, condenses, sublimes, that's not a chemical change, that's a physical change.